Hi everyone, I'm Francesca Lazzari. I'm a cloud developer advocate at Microsoft, and today we're going to talk about energy demand forecasting with Azure Machine Learning. Time series forecasting is the task of predicting future values in a time-order sequence of observations. It is a common problem and has applications in many industries. In many cases, the financial risk of inaccurate forecast can be significant. Therefore, forecasting is often a business-critical activity. This video shows how time series forecasting can be performed through applying machine learning techniques. Learn how Microsoft Azure can help accurately forecast spikes in demand for energy products and services to give your company a competitive advantage. This is a solution built on many different Azure services. This video will focus only on Azure Machine Learning and automated machine learning. This is our architecture. This scenario focuses on energy demand forecasting, where the goal is to predict the future load on an energy grid. The solution is trained on a public dataset from the New York Independent System Operator, which operates the power grid for New York State. The dataset includes hourly power demand data for the New York City over a period of 5 years. An additional dataset containing hourly weather conditions in New York City over the same period of time was taken from darksky.net. But now let's see together how Azure Machine Learning really works. First of all, what is machine learning? Machine learning is a data science technique that allows computers to use existing data to forecast future behaviors, outcomes, and trends. Using machine learning, computers learn without being explicitly programmed. So what is Azure Machine Learning Service? Azure Machine Learning Service is a cloud service that you can use to develop and deploy machine learning models. Using Azure Machine Learning Service, you can track your models as you build, train, deploy, and manage them, all at the broad scale that the cloud provides. Azure Machine Learning Service can auto-generate a model and auto-tune it for you. This is called Azure Automated Machine Learning. Otherwise, you can use the Azure Machine Learning SDK for Python along with open source Python packages, and then you can build and train your machine learning models and also deep learning models yourself in an Azure Machine Learning Service workspace. Once you have a model, you use it to create a container, such as a Docker, that can be deployed locally for testing and then as a production web service in either Azure Container Instances or Azure Kubernetes Service. You can then manage your deployed models using the Azure portal or the Azure Machine Learning CLI extensions. If you go to the page Quick Start to use Python to get started with Azure Machine Learning, you will find all the instructions that you need to install your SDK and also to create a workspace. You can also launch a Jupyter notebook. For this specific demo, I already launched mine. Actually, here there is a list of all my notebook, and I'm working on this notebook that is called AutoML Energy Demand Forecasting. In this AutoML Energy Demand Forecasting notebook, you can see also how you can create the get data file to ingest the data. In this case, we are ingesting data directly from a public blob. As you can see, there is the demand data, the web data. We can also have a closer look at the data sets. As you can see, there is the timestamp columns, the demand, precipitation, and temperature values. Starting from these points, you want to do some data pre-processing, some data cleaning. As you can see, I'm filling the gaps in this time series, and then I'm doing some feature engineering. It is clear that energy demand follows seasonal trends, so we will create features that include this information. Then you can do some extra data cleaning, and finally you can write out the training and the testing data sets. This is the most important part of this demo, because you can see how you can initiate an AutoML regressor. Here you can train the model, and the coolest part is that you can explore the results and you can retrieve the best model. So here the notebook is going to show what is the best model based on your scenario and on your data. You can also look at the best model based on other metrics. And finally, you can register the fit model for deployment, and you can also test the fit model. This short video shows how energy demand forecasting can be performed with Azure Machine Learning and automated machine learning. If you want to learn more, you can check out the link to my GitHub repo and the link to Azure Machine Learning and automated machine learning. If you don't have an Azure subscription, create a free account before you begin. You can also subscribe to Azure YouTube channel for more content like this. And finally, if you want to learn more about machine learning and Azure, just follow me on Twitter. Thank you.